We'll now build on our work on linear equations by jazzing up to linear inequalities. The only real difference between what we saw in the previous submodule and this is that we've replaced equality with these inequalities. So just consider something like, for example, y equals 3x plus 1 versus y is greater than or equal to 3x plus 1. The same set of techniques is essentially still viable. We just have to see what role the inequality plays here. How does that change the picture from being a line? Well, I will show you how. But before I do that, I want to make some remarks here, which is that there's essentially very little difference between using less than or equal to here and any of the other possible inequalities, greater than or equal to, or strictly less than or strictly equal to. It's a very small change. So let's look at an example for this. (3x plus 1 is greater than or equal to 2. Let's start with this as a warm-up. So I want to solve this inequality. I'll play the same sort of algebraic games I had before. So I'll say that 3x should be greater than or equal to 2 minus 1, i.e. 3x is greater than or equal to 1, so that x should be greater than or equal to 1/3. Fairly straightforward, I think. There is one trick I want to point out, which is that when you have negative signs and you divide by negative numbers, you have to flip the sign of the inequality. So if I have negative 2x plus 5 greater than or equal to 0, I'll say, well, this means negative 2x is greater than or equal to negative 5. But then when I divide by negative 2, I get that x is now less than or equal to negative 5 over negative 2. So 5 halves. So the key step here is that when I divide by a negative number, we have to flip the inequality. So let's now look at a visualization of this. So if I have, for example, y greater than or equal to 2x plus 7, what you want to do for this is to plot on the Cartesian plane the normal function. So we plot y equals 2x plus 7. Okay, so that's somewhere like maybe here if this is 7. So that's somehow the picture of just that. And then what does the inequality do? Well, the inequality tells us that one side of this line is the solution. So it's either what's happening above the line or below the line. So we'll quickly check a point, and we notice that it is in fact this side because I have greater than or equal to. So everything up here is a solution to the equation. So one way to check this, so to check this is the correct side, see if 0, 0 satisfies the inequality. It does not, because 7 is not less than or equal to 0, which means that the origin 0, 0 is not in the solution space. So I pick the other side of the line, which is marked in red. So this process of plotting the line first and then figuring out which side of the line you're on is extremely standard. You should at this point be comfortable with plotting lines And then the only thing we add for the inequality is to say which side of the line are you on. And the easiest thing to do is check where a point is. The easiest point is usually the origin. So I recommend doing that because it's easy to compute with zeros.